All right, welcome everybody. This is not a 10-minute or less video, all right? But it's something that you need to know, you need to be familiar with, especially now that we're using IPv6. You need to understand when they're putting in an IPv6 address that there's actually 4 bits in it. So let's talk about this real quick, because people have told me, not too many, but some, that they've had questions in their, I think more in their CCNA than their Network Plus, that they have to convert a friggin' hex number or decimal or binary or something to that effect. I think that's far and few in between. But hey, you could be that person. So when we're talking about hex numbers, okay, we're talking about numbers that each digit, each value, okay, is worth 4 bits. So let's take, for example, we use the 0. That 0 you see up here. How do we represent that 0 in hex? We put 0x0. Okay? That right there, I'm going to put it smack in the middle. That means that this is an identifier. And let's put this in lowercase. So you can, it makes a little bit more sense. 0x and then 0. This is just an identifier to let you know that this is a 0. Okay? But that 0 means 1, 2, 3, 4. Okay? That's what that means. And then you have the values for that hex number is 8241, which is going to be 0 regardless. 0 is 0 is 0. There's no what have you. All right? But know that in hex number, this is what it means. All 4 zeros. Why is that important? Because when you're dealing with IPv6, and I'm just going to put something here real quick, 2001, what I normally put when I'm doing my classes, 3200, cafe, 1000, okay? Well, let's do this, 0000, :/64. All right, so this is an actual IPv6 address with a default 64-bit prefix length, okay? But you can see that you can actually be in, because this portion of the IPv6 address, it's in it's a hexadecimal number. It's 0. Now these 4 zeros though, because we know that IPv6 address is what? 128 bits. How do you get that? Because each one of these hex values is 4 bits long. So here, to understand what this means when you're subnetting in IPv6, right? That these 4 zeros here really, I'm going to put it over here to the side, really mean, and let me see if I can like tab it over there, get close to it. All right, those 4 zeros that you see right here, these 4 zeros really mean this: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's how this section is 16 bits long, which gives you 65,536 subnets. So we really need to understand how to do this conversion. And these bit values for the hex table, for the hex numbers are identical. So if I were to come underneath here, tab, I'll go 8421 space, 8421 space, 8421 space, 8421. Right? It's still all zeros. Nothing's going to change. You're all zeros. That's cool. We do have rules, but that's another video. All right? In IPv6, when we do the leading zeros or zeros are consecutive, we can truncate it and all that good stuff. But I want you to see, because we can't do this in IPv4, they're decimal. These are hex numbers. So more than ever, we need to understand how to convert it. All right? So let me get rid of this. And I'm going to show you. All right, so I'm going to first get a normal, and here, I'm sorry, before we continue, here are your bit values for decimals, okay? People that like to put in there, hey, I want you to convert 2,382. That's just people that want you to just do math, okay? I'm not here to play around with math. We'll do no greater than 255, and that's it. It's very simple, very easy to do. And when you go take a certification, like in some videos out there, they tell you, well, if you use a calculator, no. You can't use a calculator when you go take your actual certification exam at that through Pearson VUE, yeah, you're not going to go to a testing center. Hey, I got my calculator here with me. No, you can't do that. All right. All right. So let's get a number. Let's pick a number. Let's pick a number. All right. I'm 58. I'm 58 years old. Wow. Okay. So let's tab it over. So that's the decimal 58, right? There's no 0x in front of it. So how do we convert that? Well, let's come up here. Let's play with this one up here. So, and I'm going to put the zeros where, the zeros don't count, just like your paycheck. So this is 58. So we could subtract, obviously. I'm just going to go here. Can we take out 120? No, of course not. All right. How about 64? Of course not. All right. So how about 32? Yeah. 32 plus 16 is what? 48. Okay. 48 plus 8. That's 48, right? 16 and 32 is 48. 48 plus 8 is what? Is 56. How many more do we need? Well, we need 2 more for 58. And we're going to do the math, okay? So that means there's a 0 here. Let's delete that. And there's a 0 here. So what we did, we took 32 plus 16 plus 8 plus 2 equals, right? So we got 32 and 16. That says 48. 48 plus 2 is 50 plus 8, 58. That's what that means. Now, that's how we get the binary. If you have a calculator and you're doing this with a calculator, it's not going to look that way. It's just going to look this way. 1, 1, 1, 0, 1, 0. Because zeros to the left don't count. I put it there for visualization purposes. But if you're going to go give an answer, you're just going to get zeros to the left, don't count. Same thing in IPv6 addressing. Zeros to the left, you can remove them, right? Deleting zeros, you can remove them. So zeros to the left don't count. So that's taking a decimal, 58, to the binary. So let's take this. I'm going to take this right here. I'm going to take that right there. I'm going to copy it. I'm going to bring it down here. So this is the binary, right? We'll put here decimal. Decimal, and here we got binary. Okay. So now what we do, we got to take this binary and put it in hex. And just so you know, your middle ground, whether you're going from hex to decimal, you go from hex to binary to decimal to binary to hex. And if you start with binary, you can go in either direction. So what do? I say to myself, okay, well, hex numbers, these values right here, 0, 1, 2, 3, 4, 5, 6, 7, 9, A, B, C, D, E, F, each one of these is 4 bits long. So, okay, 1, 2, 3, 4. So I separate them. I'm just going to separate them like that. Okay? And then I come underneath it and I put their bit values. 8, 4, 2, 1, 8, 4, 2, 1. Okay, so this is the bit values right here for the hex numbers. Let's move this because we're separating that binary into 4 bits. So what's on here? Well, it's 1. All right, so let's go ahead and hit enter again. Tab, 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 tab. So what's on right here? Oh, we got 2 of them on, sorry. So we take these 2 and we add them. What number is that? 3. Okay, so in this section, only these 2 are on. 1, 1. So you add them. That's 3. Okay. Well, what about over here? Who's on? 8 and 2. What's 8 plus 2? 10. What's 10 in hex? 8. So 3A. That is the hex number. But you want to tell the world, because people say, well, 3A, what is that? So, well, you tell them, well, 3A is 0x. This is the hex number to the 58 decimal number. All we did is went from decimal to binary and then to hex. And the hex, we just separated it into 4. It's pretty simple. Pretty simple. Okay? No big deal. Let's do another one. Okay. Oops. Okay. I forget that I'm in Notepad. That was 3A, right? 0 x 3A. All right, enter. So let's pick another number. Let's pick a higher number. I'll pick a number that I know off the top of my head, 224. All right. So I'm going to go ahead and turn 224 into a binary number. So let's get rid of this right here. And let's get rid of this right here. Ooh, that was messed up big time. And that's not 129, by the way. It's 128. So yes, I do typos, everyone. Okay, I do typos. I'm human. All right, so 224. I know that 224 is all right. If you add these three right here, that's 224. Okay, so that's the binary to 224. That's my decimal, 224 right here. Here is the binary version of that number. So now, what is the hex? Well, if I want to get the hex, remember, I got to separate it into bits of 4. So we know that 8 is on, 4 is on, 2 is on, and 1 is off. Here, everything is off. 8, 4, 2, and 1. So these are on only. So when we want the hex, that would be 8 plus 4 is what? 12. 12 plus 2 is 14. So that would be E. And then the other one, nothing's on, that's 0. Now let me just check my math. 8 plus 2 is 10 and 4 is 14. Yes. Okay, and then we need to put that identifier 0x right in front of it. That's it. That's all there's to that. That is all there is to that. But this is going to come in. I mean, doing this is not, major, all right? But you need to be able to work in hex when it comes to IPv6. You're going to have to, especially when you start subnetting and when you're incrementing. Because with IPv6, let's give you an example here, okay? I'll give you an example. So why do we need to learn how to convert or understand hex? And get familiar just by looking at it. Because in IPv4, let's put it in caps here, in IPv4, it's an ergonomic keyboard, okay? 224.0.0.10. This is a multicast address for EIGRP in IPv4. So let's just put it here, multicast address for EIGRP. So EIGRP sends out its triggered updates via the 224.0.0.10 in IPv4. Well, what about IPv6? In IPv6, it's FF. Anything in IPv6, the hex number FF is multicast 02 : A. Well, why A? Because 10 is A. That's why. Okay? That's why. So you need to understand that. So it will start making sense when you start getting familiarized with that conversion. And you can do it whichever way. So we've done from decimal to binary to hex. Okay? Let's go ahead and do something different. All right, let's bring this up here. Let's get rid of all this nonsense. Okay? Let's pick a binary number. I don't know. 1 1. I was gonna put 3. 0 0. That's 4, right? 1 1 3. Oops, sorry. 0 1. There you go. That's now a binary, right? It's 8, right? But we're gonna turn it. Let's turn it. We can go either way. We can go decimal. We can go hex. Let's just use decimal. So in order to do that, you need your bit values: 128, 64, 32, 16, 8421. All right, cool. So let's go ahead and turn them on. 1, 1, 0, 0, 1, 1, 0, 1. All right, cool. I know that these two together is 192. I just know that. So you got 192 plus 8, that's 200. Plus 4 is 204. Plus 1, that's 205. Okay, so let's put them here. 128 plus 64 plus 8 plus 4 plus 1 plus 1. Yeah? 128, 64, 8, 4, and then 1. That equals, again, I know that these two, which are these two right here, that's 192. And I'll show you why I know that. All right, 192. So 192 plus 8, it's 200. Plus 4 is 204. And 1 is 205. There you go. That is the decimal to this binary. The hex to this is pretty simple because all you got to do is just separate them into two parts. All right, 8421, 8421. Lovely. What's on this side? 12. Okay, so we got the 12 on the first side, on the left side. And who do we got on the second side? We got 13. All right, so 12 is what? Well, we know that A is 10, B is 11, C must be 12, and then 13 must be D. So it should be CD. Let's find out. CD. So, therefore, this binary number, let me see if I can just get you right here. This binary number is 205 in decimal, but in hex is literally 0xCD. That's what it is. No, so if you have the binary, that's even easier. You don't have to worry about it, right? Just split them in two, or use your bit values up here to turn them into a decimal. Now, so I was going to show you how I know that consecutive bits on. We're used to using for subnet masks, right? In IPv4, 255, 255, 224, 0, 255, 255, 240, whatever, or whatever it is that you're using. So it's consecutive bits on. So I have a little table. I call it the bit to decimal table. All right. So you got 1 bit, 2 bit, 3 bit, 4 bit, 5 bit, 6 bit, 7 bit, 8 bit, $1, something like that. No, just kidding. All right, so 1 bit on. What does that mean? 1 bit. Okay, that's 128. 2 bits on. That means 128 and 64. It's 192. 224. 240. 248. 252. 254. And 255. You need to know this. What does that mean? Let me show you the binary. These are consecutive bits on from right to left. 1, 2, 3, 4, 5, 6, 7, 8. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. 1, 2. Yeah. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then all the way. And this is going to be extremely important to you when you're converting a dotted decimal numbering mask, or into, let's say, Saturn notation, or I should say the other way around, a Saturn notation into dotted decimal. All right. Now this will help you to understand, to know, when you're adding this way, you know what's what. If you have consecutive bits on, you know what they are, and then it's a lot easier. Okay. But it was the case where they used to give you an IP address in binary, and you need to say which of the following. Right? They'll give you in the question a binary number, and then in the answers it was the dotted decimal format. Okay? Or they gave you, a binary or a decimal and you had to turn it into hex. That used to be the case quite a bit way back in my day. They're bringing that back because of IPv6. That's how you need to understand IPv6. That's why you can get 340 undecillion addresses. Okay? All right. So that's how I know that this is, 192. This is how I knew up here that 3 bits is 224. There's your 224. That's how I know this, right? But you need to learn your hex table. You need to learn your hex table. We know 0, 1, 2, 3, 4, 7, 8, 9. I mean, it is. That's what it is. It is. And A, B, C, D, E, F. But. Okay, know that still, even 9, all right, it's still, okay, because there's a difference between 09 and 90, right, or 90, right, because, and let me show you the difference. I mean, you probably already see it already. This 09 means 1, 2, 3, 4, and then 8 would be 8421 would be 1001. So this is 8 and this is 1. So this would literally be 0, 9, right? And then let's just put the bit value so you can have a visual. 8421, 8421. So you added 8 and 1. Okay? So if you go 90, I mean, you see it right there. It's the complete opposite. Let's copy paste this. Control C, Control V. Now it's completely the opposite. It's 0, 0, and this would be 1, 1, right? So, and let's put their value right up here, 9, 0. So what does that really change? Yes, it does. Yes, it does. Especially with, when, I don't know, we're not going to talk about voltage or anything like that, but when we're talking about IPv6 addressing, there's a big difference between 09 and 90. Because you also see this quite a bit in IPv6, and I'll put it in the center. Okay? They love to do this. 2001. Okay? DB colon DB8 colon 1, and then they could, well, I'm just gonna put a 64 just for the heck of it, but normally they'll put a 128, the whole thing, like a 32-bit for IPv4, 128-bit for IPv6. Well, they'll do that. What does that mean? Does this mean 10000? Nope. And what happened here? I thought we needed 8 sections in IPv6. So what this address really means is this. Let's do it from here. It's 2001 colon 0 DB8 colon 1234 1234. That is the network prefix of the address. Then we go to the other side. 1234 1234 1234. Let me see. We got 1, 2, 3, 4. Okay, one more set here. 1, 2, 3, 4. That's what that means. This is the short version of this expanded version of the IPv6 address. But you need to understand that this one is this right here. Okay? And that this right here in the network prefix side of the address, that is your 0 subnet. Okay? So this is very important now to understand, because your hex, right? Your hex. Because we're in IPv6. And soon we're going to be in ISIS. And ISIS, the NSAP address, it's also in hex numbers. So we need to work with it. It needs to be familiar to our eyes. So taking simple decimal numbers, you don't got to get crazy. And you got people going, well, what's 2,389? It's like, why? Why? Don't do that. Okay? Just take a simple hex numbers, no bigger than 255. And if you can go ahead and convert it, or if you wanted to, take your MAC address. Take the MAC address of a PC. Okay? And just put it out there. Okay? That's why they, and convert them from hex to binary to decimal. And then take a decimal from decimal to binary to hex. And let me show you a very simple, very, very simple number. which they explain to you in your networking, Network Plus, and in your CCNA for layer 3 broadcast and layer 2 broadcast. So you got 255.255.255.255. Well, what is that in binary? Well, that means that all these bit values, 128, 64, 32, 16, 8421 are on. So in binary, that would be 1, 2, 3, 4, 5, 6. What happened? Try it again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Because the bit values 128, 64, 32, 16, 8, 4, 2, 1. If you add all these up, it's 255. So this will be your layer 3. Now, how do we get that to a hex value, which is a layer 2 broadcast? Well, you split these two in 4 sections. So that means that there's, and if you have them all on, well, I want to show you. So let's copy paste this and I'll put it down here. So you can see how we work that out. All right, so we're going to do here, space, 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 space. Ooh, yeah, I'm good, right? Yeah. All right, so we got 2 spaces here. We got 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1. That is the value for hex numbers for 8, 4, 2, 1, 8, 4, 2, 1, and 8, 4, 2, 1. And why that is 15, right? If you add these up, you get 15. And that's the maximum, all right? F is 15. So when you add all this up, that's exactly what you get. You get 15, 15, 15, 15, 15, 15, 15, and 15. What's 15 in hex? F. Oh, so in F, you have, I mean, in layer 2 broadcast is FF colon, FF colon, FF colon, right? We got, how many we got? What? Oh my God. Okay. 1, 2. I can't keep track. My eyes. Yeah, let's put it right here. So how many do I need? 1, 2, 3, 4, 5, 6, 7, 8. Oh, we got FF, 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 oops, and then one more. FF. Right? That's 2, 4, 8, 12, 16. There you go. That's it. That's it. It's just adding the bit values, separating them to 2, and this is what you see. Okay? So you can take any number, any numbers, you feel like it. If you want to challenge yourself, go ahead and put those thousands and convert them. Just remember, you got to put every 4, that's 4 hex. Because those bit values are 4. And you can't go above 15, right, for hex. So let's say in an IPv6, well, I'm just going to use a section of it, okay? 1, 2, 3, 4, right? And you want to increment that? That's fine. Let's do that. Let's copy paste this. There's just a section. Let's say it's your subnetting section, right? You can do all zeros. This is hex values, 1. Let's say it's incremented by 1, 2, 4, 3, sorry, 3, 4, 5, 6, 7, 8, 9, all right? All right, so we got then, goes from 9, then we go to A, we go to B, we go to C, we go to D, we go to E, and we go to F. So what happens? What if we have some more, right? What's going to happen? Well, you've reached the maximum, which is F. So just like an IPv4, it resets this guy right here to 1. or it increments that guy to 1, resets itself to 0. If we're incrementing by 1, then we start all over again. 1, 1, 1, 2. And it goes all the way, right? Till you get to 0, 0, 1, F. What comes after that? 0, 0, 2, 0. And then you start 2, 1, 2, 2, 2, 3, 2, 4, and so forth. And that's how hex numbers work. Okay? So you need to start being getting familiarized with hexadecimal numbers. Definitely, this is going to be a lifesaver for you. When somebody gives you a CIDR and you need the dotted decimal notation, you know what's what, because a subnet mask is consecutive bits on, and also to help you with the math, by simple math. Oh, you got 2 consecutive bits. Oh, that's 192. So that'll help you with that. But definitely the hex numbers, remember, they're in sections of 4. Okay, that's your IPv6 addressing. Each one is 2000, whatever it is. It's in sections of 4. Each section is 16 bits, or each hextet is 16 bits. So you need to know that. All right. So understanding how to do this conversion, it's important. You may get asked a straight up conversion question, or you're working in IPv6, you're subnetting, and you need to increment. You should know how to do that. And when you're looking at an IPv6 address, if it's like because you have different types of IPv6 addresses, right? You have your FF, which I just told you, 02, let's say A for EIGRP. You may have an FE80, I think that's just a /10 right there, and there's no 2 on it. It's a big number at the end that it generates to the EUI64, but this is not the class for that. But an FE80, let's say, there's nothing else after that besides a long number. All right, well, let's put it, like, say we actually configured one. We can do that. FE80, anything that's FE80 is linked local. You have your FD 00 : 1. That's a unicast address. So you need to be familiarized looking at IPv6 addresses. It could be as simple as 2001, looking at a global unicast address, okay? But you need to be familiar with it. So when you do, because right now, if you were to do a show IPv6, the majority of us, well, I'm going to say hopefully a good portion of us, that go to our command prompt and do an IP config, we will see by default IPv6 addresses. So it shouldn't be like, oh, what is this? It should be something you should be familiar with, okay? And that's what the new book that I'm creating, I put IPv6 in the front and not in the back. I put IPv4 in the back. Because IPv4, it's over. So we need to know this. But in order to be able to be comfortable with this, these are hex numbers, and your subnetting and all these things and conversions, you need to know your hex tables, your bit values, and how to convert them. Okay? Play with it. Pick numbers, pick hex numbers. Again, you use your MAC address. Make it up. All right? Make it up, and then use your calculator to see if you're correct or not. Cool? Leave your comments. Let me know if this helped you. I need to know. And if you're having issues, where exactly are you having an issue? Okay? And yes, I did put a typo. It's not 129, it's 128. For those of you that are not going to comment, hey man, you put 129. All right? So let me know. All right? Let me know, because you really do need to be comfortable doing this. I'll see you in the next one.